Good morning, everybody. Myself, Acharya Vishvendra, and today I'll discuss a worksheet on the topic of hysteresis, which is from class 12th physics, chapter number 5, magnetism and matter. So, here is a BH curve for a ferromagnetic material as shown over here, and there are certain questions based on that. So, the first question is retentivity is given by which point? So here retentivity is given by point P, which is the value of magnetic field when the external magnetizing field is 0 when H is equals to 0. So it is represented by the point P, and its value is 20 millitesla over here. Next is coercivity. So coercivity here is given by point Q. Coercivity is the H coordinate when magnetic field is 0, or in a way it is the magnetizing field required to demagnetize the material for making magnetic field as 0, and here its value is 10 millitesla by mu naught. It is the magnitude. In fact, it's negative in the sign, so it's better to use minus of 10 millitesla by mu naught. Then we have saturated magnetic field. So saturated magnetic field is when magnetic field does not increase, and it is given by here 30 millitesla. Next is area under BH curve represents. So area under BH curve represents the magnetic energy density stored in the system in this hysteresis curve. Next are questions on the basis of magnetic susceptibility. So for this material, magnetic susceptibility chi is 499. We need to find, the first question is relative permeability. So it is 1 plus chi, so 1 plus 499, which will be equal to 500. Next is we need to find permeability, so that is mu naught into mu r. Mu naught, mu r here is 500, so that will be 500 into mu naught. So in this way you can find mu. Next question is find magnetic field. So we know that magnetic field finally is equals to mu into h. So h here is 20 millitesla. So the magnetic field corresponding to that point will be 500 mu naught into 20 millitesla by mu naught, and after solving it, we get the answer as the 10 Tesla. Then we have the question that a solenoid has number of turns 500 turns per centimeter. A material is filled in the solenoid with chi is equals to 999, and a current of 50 ampere is flowing in it. Then we need to find the relative permeability. So that is given by 1 plus chi, which is 1000. Then is permeability of the medium, so that is mu naught into mu r, which will be 1000 times mu naught. Then is the magnetic field. So magnetic field will here be mu ni, so that will be 1000 mu naught into n into I. And after substituting the values, we can calculate the magnetic field. Now there is another question that without material, by how much current should be changed so that magnetic field is same. Now we can say that B dash is equals to 1000. This is the mu naught ni is the magnetic field without the material. So we can say that the magnetic field after introduction of material has become 1000 times of that without the material. So we can say that B dash is 1000 times B. So the change in magnetic field will be B dash minus B, which will be 999 B. So change in magnetic field is 990 times original. So we can say that correspondingly change in current, because it is proportional, so delta B will be proportional to delta I. So we can say that delta I will be 999 times I. That means if you want to have the same magnetic field without material, you will have to increase the current by 999 times. Then our concept of magnetization. So magnetization is magnetic moment per unit volume. Then we have magnetic field due to the material itself. So due to magnetization, Magnetic field will be mu naught times vector m, which is magnetization. Then is BH, which is the magnetizing field intensity. So it is mu naught times vector H. Then we have net magnetic field, which will be vector sum of Bm plus Bh. So that will be mu naught into m plus h. Here is one more thing. Actually, m is equals to chi into h for linear materials. So for that special case, we can write it as mu naught chi h plus h. So that gives us mu naught chi plus 1 into h, or this is chi plus 1 is mu r h. So there is one important concept over here. It can also be related to like this. Then is what type of material is to be used in electromagnets. So electromagnets are temporary magnets which become magnetic only when electric current passes through it. So certainly it need to have high coercivity, low retentivity, so that it is acting as a electromagnet and it does not retain magnetism. So that's why it should have low retentivity and high permeability, so that the magnetic field created inside the material is strong. Then is which type of material should be used for making permanent magnets? So obviously for making permanent magnets, these should have high retentivity so as to retain the magnetic field. Then is high coercivity, because of the same logic, so that magnetic field is able to be retained, and high permeability. So you see, if you compare the two terms, it is the retentivity which differentiates. In electromagnets we have low retentivity, and in permanent magnets we have high retentivity. Then is why soft iron is used for making electromagnets? So because of its high coercivity, low retentivity and high permeability. I repeat itself: high coercivity, low retentivity, high permeability. Then is why steel is used for making permanent magnets? So it is because of high retentivity, high coercivity, high permeability, and these questions are being asked many a times in NEET and JEE Main. So important concepts are there. They have been used for in PYQs. Then is we need to find dimensional formula of magnetic field. So we know that force is equals to QVB. So from here magnetic field will be Q F upon QV. So dimension of magnetic field will be dimension of force upon dimension of charge into dimension of velocity. So force has dimension mLt minus 2, charge has I1T1, velocity L1T minus 1. So comparing all these terms, we have the dimension of formula of magnetic field as M1 L0 T minus 2 and I minus 1. This is the dimensional formula of magnetic field from over here. Then next we have dimensional formula of magnetizing field. So it has same dimensional formula as that of magnetization, which is magnetic moment per unit volume. So magnetic moment has the dimensions Ia, volume has the dimension L3. So we have the dimensional formula of magnetizing field as IL minus 1. Then we have dimensional formula for B by H. So as we have calculated, dimensional formula of magnetic field is M1 L0 T minus 2 I minus 1, and that of magnetizing field is I1 L minus 1. So from here if we calculate, the dimensional formula of B by H will be M1 L1 T minus 2 I minus 2. Then we have dimensional formula of B into H. So multiply the two terms. We have dimensional formula as M1 L minus 1 and T minus 2. Then we have dimensional formula of integration BDH. So that will be having dimension as B into DH. DH has same dimension as that of H. So we will have the dimensional formula as M1 L minus 1 T minus 2, which is same as that of energy density, pressure, stress, modulus of elasticity, Young's modulus, bulk modulus, modulus of rigidity. So all of these have the same dimensional formula, M1 L minus 1 T minus 2. So these worksheets are designed to optimize your time and energy so that you can complete all the basic concepts, all the basic terms, all the graphical and mathematical analysis corresponding to a particular video, which enhances your problem solving skills, develop your mind brain system, makes your mind brain algorithms stronger and complex, improves your efficiency. So it's an overall optimization of your mind brain system for cracking JEE NEET. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.